So what we're going to look at is classifying the systems. All right, so classifying the systems of linear equations. So remember the first thing we did was we graphed the systems, and when we graphed, we only did one, but when we graphed it, it intersected, right? And it intersected. Those two lines intersect at one point, and so this was your solution right here. All right, so this system had a solution. So this system, the system right here, we call a consistent system. In the past, you used the word conditional. With the system, we're going to call it consistent. All right, so here's a possibility when you graph. When you graph a system, they can intersect at one point. So when you graph, they could intersect at a point like this. So your two lines could intersect, right? In which case you would have how many solutions? How many solutions would you have? One. You'd have one solution. Okay, so we're going to call this a consistent system. So a consistent system is where you have at least one solution. Or at least one solution. All right. When I graphed these, they could have ended up being like this as well. So your two lines could have looked like this, in which case they did not intersect. So if your graphs, and we haven't done one like this with the graphing, but if the graphs don't intersect, then how many solutions are there? Okay, the graphs do not intersect. So how many solutions are there? There aren't any. They don't intersect. Remember, we said that a system, the solutions where the graphs intersect. Well, if they don't intersect, there aren't any solutions, right? So there's no solution. No solution, so we'd say that this is inconsistent. So this system is an inconsistent system. Consistent is where they have at least how many solutions? One. Inconsistent is where they have no solution. Or the two lines could have done this. Now you got to listen carefully. And you're going to see this in one of the problems you're going to look at. Where the two lines overlap. All right, so my two lines, they overlap. So how many solutions are there? Infinite. An infinite number. This one has an infinite number of solutions. Okay, so this has an infinite number of solutions. Now you will see in a little while how to write the solution, but it has an infinite number of solutions. This has one, this has none, this has how many? All of them. No, don't say all of them. It has an infinite number. It has an infinite number of solutions. Now remember, consistent system, a system is either consistent or inconsistent. Inconsistent is where there are no solutions. Consistent is where there's at least one solution. So this has an infinite number. It's at least one solution. So it's consistent as well. Okay? All right. Now, let's look at this system. Number one. Solve by any method except cheating. Solve by any method. So on the test, on the final, there might be one problem where it says solve by any method. Now, when I say solve by any method, I mean the method we talked about, right? Not the method where, hey neighbor, what do you have? All right, solve by any method. So here's my system. X equal 3y plus 6, 2x minus y equal negative 3. So given this system, which method might be the easiest to deal with?
Substitution.
Substitution. That would be the easiest to deal with because the first equation, the variable x is already by itself. So use substitution. That's the easiest to deal with. So you're going to take that first equation. The variable x is already by itself. So all I got to do now is go to step 2. And step 2 says I go to the other equation, and wherever you see the variable x, what do you substitute? 3y plus 6. So I get 2 times, in parentheses, 3y plus 6 minus y equal negative 3. All right, so use the distributive property. What's 2 times 3y? So I get 6y plus 12 minus y equal negative 3. Combine like terms, I get 5y plus 12 equal negative 3. Subtract 12 from both sides. I get 5y equal negative 15. Negative 3 to negative 12 is negative 15. So that makes y equal to a negative 3. So that's your y coordinate of your solution. To find the x coordinate, you just go back to step 1, and where we see the variable y, you're going to plug in negative 3. So I get x equal 3 times negative 3 plus 6. So that's negative 9 plus 6, which is negative 3. So is this system consistent or inconsistent?
Consistent.
Consistent, because you have at least one solution. So the system is a consistent system. So this is a consistent system because you have at least one solution. Okay? All right, number 2. So it's easier, did you use substitution? Now, yes? What's your question?
Finding a single solution for x? Like
I did. Negative 3, negative 3. Y is negative 3, x is negative 3.
Oh. Yeah.
Suppose someone else wanted to use elimination. Let's see what you would have done if you had used elimination. But it's easier to have used substitution, right?
Mm-hmm.
Okay, so let's do the same problem but use elimination. Okay, so if I'm going to do this by elimination, then what's going to happen is I've got to bring all the variables on one side and align them up. So remember all the elimination problems we had? We had the x's under each other, the y's under each other, and what was on the other side of the equal sign? The constant. So what I got to do here is I got to bring the variables on one side in that first equation. So in other words, I'm going to rewrite that first equation as x what? Minus 3y equal 6. All right, and just rewrite the second equation. So that's what you have to do first, is that. Now, which variable do you want to eliminate? The x. So what's the least common multiple for the x?
2.
2. So the second equation already has a 2. I just need the first one to have what coefficient?
Negative.
A negative 2. So let's go ahead and rewrite this. All right, so I'm going to multiply the first equation by what, though? Negative 2. So this becomes now the system. Distribute, what do you get for that first equation? Negative 2x plus 6y equal negative 12. Second equation, 2x minus y equal negative 3. Now I can add them, right? So when I add them, what do I end up with? 5y equal negative 15, so y equals what? Negative 3. You said -5. You knew something was wrong because in our previous problem we end up with -3. All right, now to get the x coordinate, I just do substitution. Now you could do elimination again, but let's just do substitution. It's quicker because look, I'm just going to go back to the original, and in place of y, what will I substitute? -3. So I get x equal 3 times -3 plus 6. So that's -9 plus 6, which is -3. So that's what you would have done if you had used substitution. You had to bring the variables one side, constants to the other, and you eliminate one of the variables.
So in the very, very first step, whenever we rewrote it, we are rewriting it so it matches the second, oh my gosh. Can't think of the word.
What's your question?
So we rewrite the x equals 3y plus 6. We
When doing
rewrite that.
elimination, remember you got to eliminate one of the variables.
Right.
So your variables have to be aligned.
Okay.
They have to be aligned. So they're not aligned here. So you got to bring all the variables one side, constants to the other, and align the variables. Put the x on each other, put the y's on each other. So you got to get those variables to be aligned. So x's, y's, and your constants. All right, let's look at number 2. Suppose in number 2 I had this. You had 2x minus y equals 7, and then 6x minus 3y equal 14. Okay. So let's just use elimination. It's easier to deal with that. If I'm going to use elimination, which variable might be the easiest to eliminate? The y. And all I need to do is multiply the top equation by -3.
Why?
Because you have to get the y.
Because that's a -3, because that has to be a +3, this is a -3.
Yeah. Would it be
What?
just
Okay, so now if you want to eliminate the x's, the least common multiple is 6, right? So you'd have to multiply the top equation in that case by -3.
So when that just cancels out 8 and 1.
We haven't gotten that far yet. Okay? All right. So we're going to eliminate the y's, right? So I get 2x minus y equals 7, and then 6x minus 3y equal 14. So I'm going to multiply the top equation by -3. Is that right? When I do that, here's what I get. I get, that was a -3 right here. So I get -6x plus 3y equal -21. And I get 6x minus 3y equal 14, right? Now add them up. What happens to the variables? So that's a 0, right? So the left side 0 equal a -7. Now you remember we did linear equations last time where the variable disappeared? And we see that 0 equal -7 is a false statement. So what that means in terms of your solutions? There aren't any solution. So there's no solution. So that's what you put in the blank, no solution, or you could do the empty set. Now that means that if you were to graph those two lines, they would be parallel. That's what they mean. So that means that these two lines, this means that the graphs of the two lines are parallel. Meaning that they don't intersect, right? So they don't intersect. If they don't intersect, then there's no solution. But that should look very similar to what you did when you solved the equations. And remember, we solved the equations, you did have some where there were no solution. So in that case, at one point, the variables were no longer there, and so the statement was a false statement, so you say no solution. Now, is this system right here consistent or inconsistent? Inconsistent. So the system is inconsistent. Inconsistent. All right. Finally, number 3. Let's look at number 3. Suppose in number 3 we had this. 2x plus y equal 8. And 3x plus 3 halves y equal 12. Okay, so this is the first one where we had, like, in our original problem, a fraction like this. Okay, so make things easy on yourself. What I would do first is kind of remember something we've had in the past. So in the past, and on test 1, when you had a fraction like this, what did you do first of all? You cleared the fractions, right? So you multiply both sides by the LCD. What's the LCD here? 2. So that's what I would do first. So I would multiply both sides by 2. Okay, so I would clear the fractions. So that way I wouldn't deal with fractions here. And so I'm just going to rewrite this. So I'd multiply both sides by 2, right? So in a distribute, what's 2 times 3x?
6.
What's 2 times 3 halves?
Oh.
No, it's still 6x, but what's 2 times 3 halves now? 6 over 2, which is 3. So 3y, right? Equal 24? All right, so that's what this becomes. So this becomes this. 2x plus y equal 8, and then 6x plus 3y equal 24. So that's what I end up with. So I just clear the fraction. All right, now, what method do you want to use now? You want to use elimination, substitution? It doesn't matter. Elimination? All right, so if I'm using elimination, let's go ahead and get rid of the y's. What's the least common multiple of the y's?
-3.
3. So I need to multiply the top one, though, by what?
-3.
-3? All right, so let's do that. So I'm going to just rewrite this over, and I'm going to multiply by -3, just like this. And so if I distribute now, notice what happens. I get negative 6x minus 3y equal negative 24, right? And then 6x plus 3y equal 24. Okay? Once you get to that point, what's your next step? Add. And when I add, I get 0 equals 0. The variable disappeared, but what do you notice about this statement?
That's true.
It's true. So remember, the variable disappeared. You get no solution or all real numbers. Which one is it? All real numbers. Now, remember, these are points, though. These are points.
Start at the
So you have to be specific in terms of your points. If you say any point works, that's not true, because if you look at the coordinate plane, is this right here, is this point I'm pointing to a solution to one of those lines? No. So I can't just say any point is a solution. So you got to be a little bit more specific than that. Because not every point in a plane lies on a line. Even though we say there's an infinite number of solutions, it is true there's an infinite number of solutions, but there's a lot more points elsewhere. Okay, so here's how you're going to say this, though. And on MATLAB, this is how you're going to write it. You're going to say it like this. Your solution is this. There's an infinite number, though, right? You're not going to say the word infinite number, though. You're going to be a little bit more specific. You're going to say this. The solution is this. It's the set of points. Now, the point has what coordinates?
0, 0.
No, a point has what coordinates? X, Y. So set of points, X, Y, such that, this means such that, And then all you do is just write one of those equations over, such that, and just let's just rewrite the first one, such that 2x plus y equal what? All right, and that's all you do. So your solution, so in other words, your solution has to satisfy this equation, right? Does any point in the plane satisfy that equation? Does any point in the plane satisfy that equation? No. Only the points that lie in this line. So that's why you got to use the equation, this equation here. So in my math lab, here's the way it's going to look in my math lab. They will have this already. They'll have this right here. They will have this already. You got to fill in this blank. So what are you going to put in this blank? 2x plus y equal 8. Or you could have done the second one. Didn't matter. Doesn't matter. Okay? All right. Now, is this consistent or inconsistent? Consistent because it has at least one solution. It has an infinite. So this is consistent. Okay? All right. So if it has no solution, like we did in the second problem, right here, you're going to end up, when you add them up, you end up with the variables disappearing, but that statement is false, right? In terms of the graphs, it means the two graphs do what? They're parallel, so they don't intersect. If the variable disappears and you get the statement z equals 0, that's a true statement. So that means you do have solutions. How many solutions are there? An infinite number. You can't list them. So you're gonna state the solution set this way. You're gonna say set of x, y such that, and then just rewrite one of those equations. All right. And then the only other case is where they intersect at one point, in which case you just say the solution. It's just a point. Right here. It's just this point. Okay? All right. All right, so consistent or inconsistent? Now, the only difficult part will be for you, should be, which really it shouldn't, but it should be how to write it if it's an infinite number. You're going to write it like this. Is that clear? Mm-hmm. All right. So I'm not going to give you that worksheet today. I'm going to give you that worksheet next class period, but just when I give it out, I'll remind you about this part right here.
Now in my math lab, it'll just like have it will.
On my math lab, it will have this part. You're going to have to fill in the underlined part. So you just fill in the equation. You just write the equation. And it's just one of these.
What was on the first page, what was the title of the section? What did you write?
Classifying systems of linear equations. So either consistent or inconsistent. Okay, now